in the cloud. Because Google has 9 services with more than 1 billion users, security is always on the minds of Google's employees. Design for security is prevalent throughout the infrastructure that Google Cloud and Google services run on. Let's explore the 5 layers of protection Google provides to keep customers' data safe. Hardware infrastructure, service deployment, storage services, internet communication, and operational security. First, the hardware infrastructure layer. Hardware design and provenance. Both the server boards and the networking equipment in Google data centers are custom designed by Google. Google also designs custom chips, including a hardware security chip that's currently being deployed on both servers and peripherals. Secure boot stack. Google server machines use various technologies to ensure that they are booting the correct software stack, such as cryptographic signatures over the BIOS, bootloader, kernel, and base operating system image. Premises security. Google designs and builds its own data centers, which incorporate multiple layers of physical security protections. Access to these data centers is limited to only a small fraction of Google employees. Google also hosts some servers in third-party data centers, where we ensure that there are Google-controlled physical security measures on top of the security layers provided by the data center operator. Second, the service deployment layer. Encryption of inter-service communication. Google's infrastructure provides cryptographic privacy and integrity for remote procedure call (RPC) data on the network. Google's services communicate with each other using RPC calls. The infrastructure automatically encrypts all infrastructure RPC traffic, which goes between data centers. Google has started to deploy hardware cryptographic accelerators that will allow it to extend this default encryption to all infrastructure RPC traffic inside Google data centers. User identity. Google's central identity service, which usually manifests to end users as the Google login page, goes beyond asking for a simple username and password. The service also intelligently challenges users for additional information based on risk factors, such as whether they have logged in from the same device or a similar location in the past. Users also have the option of employing secondary factors when signing in, including devices based on the Universal Second Factor (U2F) open standard. Third, the storage services layer. Encryption at rest. Most applications at Google access physical storage, in other words file storage, indirectly by using storage services. Encryption, using centrally managed keys, is applied at the layer of these storage services. Google also enables hardware encryption support in hard drives and SSDs. Fourth, the Internet communication layer. Google front-end. Google services that want to make themselves available on the Internet register themselves with an infrastructure service called the Google front-end, which ensures that all TLS connections are ended using a public-private key pair and an X.509 certificate from a certified authority, CA, and follows best practices such as supporting perfect forward secrecy. The GFE also applies protections against denial of service attacks. Denial of service (DOS) protection. The sheer scale of its infrastructure enables Google to simply absorb many DOS attacks. Google also has multi-tier, multi-layer DOS protections that further reduce the risk of any DOS impact on a service running behind a GFE. Finally, Google's operational security layer. Intrusion detection. Rules and machine intelligence give Google's operational security teams warnings of possible incidents. Google conducts red team exercises to measure and improve the effectiveness of its detection and response mechanisms. Reducing insider risk. Google aggressively limits and actively monitors the activities of employees who have been granted administrative access to the infrastructure. Employee U2F use. To guard against phishing attacks against Google employees, employee accounts require use of U2F-compatible security keys. Software development practices. Google employs central source control and requires two-party review of new code. Google also provides its developers with libraries that prevent them from introducing certain classes of security bugs. Google also runs a vulnerability rewards program where we pay anyone who can discover and inform us of bugs in our infrastructure or applications.